Cooking isn't just about throwing things into a pan and hoping for the best. It's a science, it's an art. And the more I dive into it, the more I realize that every little thing we do in the kitchen, from frying onions to adding a splash of lemon juice, is pure chemistry and physics at play. And that's exactly what makes Masala Lab, the Science of Indian Cooking by Krish Ashok, so mind blowing. If you caught the last video, you already know we talked about heat transfer, cooking chemistry, and how flavors develop. If you missed that one, I definitely recommend checking it out first because it sets the stage for what we are getting into today. Let's talk about browning. Ever noticed how food becomes so much more flavorful when it gets that golden, crispy, caramelized texture? Think about a perfectly seared steak, crispy dosa, or even gold fried potatoes. That deep, complex, mouth-watering flavor? Yes, that's all thanks to browning. But here's the cool part. It's not just one thing happening. Browning actually happens in multiple ways, and each one affects the taste differently. Onions are the perfect example. Almost every Indian dish starts with onions sizzling in hot oil. Raw onions, super sharp, kinda irritating to the eyes, right? That's because they're packed with sulfur compounds. But once they hit the heat, those compounds start breaking down, and suddenly the onions turns soft, golden, and sweet. The same thing happens with garlic. It starts off spicy and harsh, but once it's cooked, it mellows out into something rich and aromatic. But here's where it gets tricky. Garlic browns way faster than onions, and burnt garlic, it's bitter and it completely ruins the dish. That's why when you're cooking onions and garlic together, onions always go in first. They have more water content and take longer to caramelize. Now, caramelization is just one part of browning. It happens when sugars break down under heat. That's why roasted veggies, caramelized onions, or sweets made with jaggery have that deep, rich taste. But Indian cooking takes it up a notch with something even more powerful, the Maillard reaction. This is where proteins and sugars interact under heat, creating an explosion of new flavors. You know that brown spots on a perfectly cooked roti? Or that incredible smell when meat gets a good sear? That's the Maillard reaction at work. Unlike caramelization, which is just about sugar breaking down, Maillard reactions need both amino acids, which is proteins, and sugars to create those next level flavors. Alright, let's talk about frying. Arguably the best cooking techniques out there. Don't fight me on this. Frying works instantly evaporating moisture from the surface of the food while locking in all the juicy goodness inside. When the food hits hot oil, the water on its surface turns into steam, pushing outward and forming that crispy golden crust we all love. But here's the thing, frying isn't just about dunking food in oil. The oil type, temperature, and timing makes a huge difference. Oils with high smoke points like peanut or sunflower oil are best for deep frying. Flavored oils like sesame or mustard oil work better for stir frying or seasoning. Temperature matters. Too low and your food soaks up oil and turns greasy. Too high and it burns before cooking through. Let's take potatoes as an example. Raw potatoes, just starch and water. But the moment they hit hot oil, Maillard reaction plus caramelization equals crispy golden brown perfection on the outside and soft fluffy goodness on the inside. It mouth waters literally. That's why French fries and potato chips are so addictive. They hit the sweet spot of the crispy on the outside and soft inside and packed with umami flavor. Okay, enough of yum. Let's switch gears and talk about acidity. Because as much as heat and browning bring out flavors, acidity is another key player in making food taste incredible. We've all used lemon juice, vinegar, tomatoes, and even yogurt. But have you ever thought about what they actually do to your food? It's not just about sourness. Acids help balance flavors, break down proteins, and even preserve food. And ever wondered why tandoori chicken is so tender despite being cooked at high heat? It's because yogurt in the marinade breaks down the muscle fibers. That's the power of acidity. Same with tamarind. It's loaded with tartaric acid, which gives it that deep, tangy taste. But unlike lemon juice, which is bright and sharp, tamarind has a mellow sweetness, making it perfect for balancing spicy and savory flavors. Here's a cool kitchen experiment. Cook red cabbage in plain water and it turns blue, but add a little vinegar, it stays red. That's because pigments in cabbage are pH sensitive. This also explains why some pickles get that vibrant color when acidic ingredients are used. Okay, we all know sweet, salty, sour, and bitter, but there's a fifth taste: umami. It's what makes slow cooked broths, aged cheese, mushrooms, and fermented foods taste so rich and satisfying. Umami comes from glutamates found in foods like tomatoes, soy sauce, and parmesan cheese. That's why dishes with umami rich ingredients taste amazing, even if they're not loaded with salt or spice. Let's take dosa as an example. When dosa batter ferments, the carbs break down, producing lactic acid, which not only makes it slightly tangy but also enhances its umami flavor. Then, when you cook it on a hot tawa, the Maillard reaction kicks in, creating that beautiful golden crust. That's why a great dosa is both crispy and complex in flavor, with a perfect balance of sourness and umami. Another surprising aspect in the book: we don't use alcohol much in Indian cooking, but it plays a huge role in flavor extraction. But why? Because alcohol can dissolve fat soluble compounds that water can't. That's why in Western cooking, wine is often used to deglaze pans or enrich sauces. Even in Indian cooking, understanding this concept helps us extract maximum flavor from spices and aromatics. Again, there's so much more to explore, but this gives you a solid understanding of how browning, acidity, and umami work together to create delicious food. And guess what? This is just part 2 of our Masala Lab series, and I highly recommend reading this book to get deeper. So, in the next episode, we'll dive into more from the book. Again, if you enjoy this, hit that subscribe button and stay tuned for more content.